Today's lesson is on scientific notation application problems. So, taking what we know about adding, subtracting, multiplying, dividing in scientific notation and applying them to story problems. And so, it's really the same as a normal word problem, just we don't want to make sure we don't overthink on this. So, start with this review. If we have 4 cookies per person and we have 10 people, how many cookies do we need? If you have 30 pounds of cement and a pot weighs 5 pounds, how many times greater is the cement versus the flour pot? And if Si walks 3 miles an hour for 4 hours, how many miles did he walk? I want you to pause the video and think about these problems and think about what operation are you using to solve. I know that if I have 4 cookies a person and 10 people, I need 40 cookies because I had to multiply 4 times 10. I know 30 pounds of cement versus a pot that's 5 pounds. How many times greater? Well, 30 divided by 5 would be how many times greater? 6 times greater. And it's a division problem. And if Si walks 3 miles an hour for 4 hours, he walked 12 miles total because we had to multiply 3 times 4. So if you can figure out these simple problems, you can figure out scientific notation. The biggest thing to keep in mind that when we're working with problems in scientific notation, all operations must be in scientific notation as well as our work needs to be in scientific notation and any numbers. So just keep that in mind as we go through this. Our first problem says the average American eats 80 pounds of veggies a year. There are 300 million Americans. Find the number of pounds of vegetables consumed each year in the United States. So how many pounds of veggies are eaten every year? I like to start these problems by switching to using really easy numbers. So I'm going to turn 80 into 8 and 300 million into 3. So if I think about this with easy numbers, the average American eats 8 pounds of vegetables each year. There's 3 Americans. How many pounds of veggies did we eat? Well, I know I would have to multiply to figure this out. When I have those nice easy numbers, and now I know what operation I'm going to use. I just need to do it with scientific notation. So first, think about our problem in standard form. I need to take 80 pounds of veggies times 300 million. So I'm going to write that out in a number. Times 300 million people. But I said all of our work needs to be in scientific notation. So first we have to put 80 in scientific notation. 8 times 10 to the first power. And I need to multiply that by 300 million. So it's 3 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8th power. And now I just have to go ahead and solve using what I know. I know when I'm multiplying, I'm going to do 8 times 3, which is 24, times 10, and I'm going to add my powers. 1 plus 8 is 9. Now, 24 times 10 to the 9th is not in scientific notation. I need to make it 2.4, and then I'm going to have to add to my exponent, times 10 to the 10th power. And I have that many pounds of veggies. Making sure we're labeling what our number is representing. This number is how many pounds of veggies are eaten each year in the United States. Before we can begin the next problem, I want to talk about our triangle over on the side. This triangle over here is our distance formula triangle. And it just gives us a formula. Distance equals rate times time, because rate and time are next to each other. We can also rearrange this to say rate, and this is division, equals distance divided by time. Or we can look at the other way and say time equals this division over here distance divided by rate. We can get 3 formulas out of this one little triangle, just as a helpful way to remind us what we're trying to figure out. Now, in this problem that we're given, it says the distance from the sun to Earth is 5.1 times 10 to the 11th meters. The time it takes for sunlight to reach Earth is 5 times 10 to the second power seconds. How many meters per second is that? So I know meters per second is a rate. That's what I'm trying to figure out. So if I look at my formulas, I need to use this one in the middle. Rate equals distance divided by time. So I'm going to take my distance, which was 1.5, sorry. 1.5 times 10 to the 11th power, and I'm going to divide that by the time. 5 times 10 squared. And now I just need to figure out what this problem is. 1.5 divided by 5. I can solve that mathematically. And when I do so, I know it's like 15 divided by 5, which is 3, but there's a decimal, so it's 0.3 times 10, and I'm going to be subtracting my power. Same base in a division problem, we subtract, so 11 minus 2 is 9. Now, I am not in scientific notation, so I'm going to have to shift my decimal. I'm going to move it 1 to the right to make 3, which means I can subtract 1 from my power. So 3 times 10 to the 8th, then we got a label. That's how many meters per second. Meters per second. That is the speed that the light is traveling. Our problem says, it should say Mr. D ate 4 times 10 to the 8th pieces of popcorn in 2018. Miss Kennel ate 3 million pieces of popcorn in 2018. We need to figure out how many more pieces of popcorn did Mr. D eat than Mrs. K. So, how many more? How many more? I'm not quite sure what operation to use, so let's use easy numbers. Mr. D ate 4 pieces of popcorn, and Miss Kennel ate 3. How many more pieces did he eat? Well, he ate 1 more piece because I am going to subtract. When I have easy numbers, it makes me find those operations a lot easier. I know 4 is 1 more than 3. I figured that out by subtracting. So how many more is a subtracting problem? Now, I need to think about what this is looking like. I'm going to have Mr. D, 4 times 10 to the 8th, minus 3 million, which looks like this. But it needs to be all in scientific notation, so I got to convert that to scientific notation. So I have 4 times 10 to the 8th for Mr. D, minus 3 times 10 to the 6th power. Now when I subtract, they have to have the same exponent when we subtract. So we need the same exponent, remember that. So I'm going to turn 3 into 10 to the 8th. So I need to add 2. So I'm going to move my decimal over 2 spaces. So my new problem is 4 times 10 to the 8th minus 0.03 times 10 to the 8th. Now I can go ahead and subtract my numbers. Well, that's 3.97, and then I recopy my power, times 10 to the 8th. So he ate 3.97 times 10 to the 8th more pieces of popcorn. So making sure we explain what that number means is just as important. When we work in scientific notation, the numbers look complicated, but when we switch them to those easy numbers, we can quickly find our correct operations.